I'm a believer in this. Farmers working through the conservation districts, they can get a lot of things done, and they don't have to always follow the same standards that we have with some of the other agencies. We kind of approach our field, we're talking about field implementation of practices, kind of a three-legged stool. You've got to control erosion, high-level nutrient management, much higher than what maybe GAMS is going to offer. And then, if the opportunity is there, treating surface water and subsurface water before it goes into a stream. Like I said, soil erosion, I've been told, I've read it, 65% of all total phosphorus is coming from field soil erosion. If we're going to make a difference, there's no sense dealing with dissolved reactive phosphorus if we don't control erosion first. So keep that in mind as part of our system. Working at a high level of nutrient management through some of the projects that the Conservation Office is involved in with EGLE, we are working with nitrogen sensors where we're actually applying nitrogen in the field based on what the crop needs. It's my understanding that the combination of nitrogen and phosphorus works together on the algae issue in Lake Erie. And the other one we're working on, it's real simple. If we use less phosphorus in the system, will that not help on what we're trying to do? Here's an example of what we call our phosphorus reduction program. You can see this is a soil phosphorus map. You guys have seen these grid sample, 2.5 acre grids. And you can see that the range of phosphorus ranges from 15 to 96 parts per million. The green areas are higher, the red areas are low on the phosphorus map. This is actually a 2-year spread that Tri-State Fertilizer, that Precision Ag Services put together for this farm. And you can see the field's 82 acres. The average application is 124 pounds per acre of MAP. That's a product, ammonium phosphate, that would be used here in a normal situation. Corn bean rotation, snow-tilled, surface applied fertilizer, and no-till cover crops. And then if we raise the threshold of Tri-State fertilizer recommendations, when I say raise it, lower it to 10 parts per million. Don't put any fertilizer on anything unless it's less than 10 parts per million. And so that's what this is. And you can see we went from 124 pounds per acre to, let me see, what does it say, 0.5 pounds per acre. Now, these are field level projects. You can see, is the pointer on the top here? We have strips in the field. That's crop removal strips that we sample for yield, okay, to see if there's any difference. And in 2022, we had 562 acres, you can see it right there, involved in the program, and we converted the 2-year spread to a 1-year spread, and we had 98.3 pounds per acre, so 1-year spread in all these fields. If we used a less than 10 parts per million, we only were spreading about 14.5 pounds. Now this is all science-based soil tests. We're just lowering the levels that we put fertilizer on. Well, on these fields, we saved about 40,000 pounds of MAP. At $880 a ton, that's $17,000. Now, why would agriculture want to spend the money if you don't need it? And I'm not saying to you that phosphorus isn't needed by the crop. It's going to get it from another source, especially if you have good soil health and are following a systems approach to water quality and good crop production. The other thing I wanted to point out, you can see the yields here. These are yields this is bushels per acre for the 10 parts per million, and there are no significant difference in yields. Here's the 1-year crop removal yields. So we're tracking these yields. We're going to do it for 3 years and and they're going to continue putting those crop removal strips in, and maybe I can report to you someday on that. Okay, what else have we been up to? We've been looking at livestock waste handling, always a big issue. And we asked the question, could we spread livestock waste at a variable rate in a field? And we were looking for 3 goals. Can we do it? Can we physically do it with the equipment? Can we reduce the amount of phosphorus we're putting on the fields? And what's it going to cost to do it? So when designing a variable rate livestock waste application program, we looked at the soils, we developed a soil P map, we set up zones based on the soil P map, and then we had to also determine the equipment limitations. So I can't drive a tractor at 10 miles an hour pulling, 20 tons of manure. How slow can I go to make it, economical? That's a decision that the farmer that was working with on us made those decisions. So here's some of the data. We're using 210 bushel corn. Again, this is at the field level, 100-acre field. The nutrient levels of the waste with 8.8 pounds of P2O5 per 1,000 gallons. And we had to, his normal application rate was 12,000 gallons per acre based on that. And so we had to factor some of those things in. So here is the soil phosphorus map. You can kind of see that the green areas are high in phosphorus. The red areas are low to very low. And then the yellow-orange are in the medium level. And so we're using the phosphorus map to kind of develop our prescription. And so here is the prescription that we came up with. So the areas that are low in phosphorus, we went with a 2 times crop removal. It's totally within the GAMPs. And then the red zone, no application. And this is the as-applied. So this is the as-applied map, and if you look at it, we weren't able to meet all our goals as far as some of the zones, but we were able to go from a crop removal rate, pretty much the green areas, and a crop removal. Remember, that was the 2 times crop removal, and we figure he'd go there and spread that a second time, maybe in the fall. The yellow areas, we put on 5,000 gallons, and the orange areas, 4,000, and then the red-orange areas down to 3,000 gallons. So it wasn't quite what we prescribed, the as-applied, based on the speed of the tractor, tweaking that. But I will say this, we were able to save 515,000 gallons of waste and about 4,000 pounds of P2O5 from the variable rate. So we know we can do it. It's not that expensive to do equipment-wise, but how do if I'm spreading less here, I've got to spread it somewhere else. The cost of transporting the manure is an issue to make this work on a large operation. But it can be done. Little thank you for EGLE and their conservation planning tool. I love it. I wish I would have had this when I worked for USDA for 30-some years. This is Lime Creek. And I took an individual field here, and I overlaid the LiDAR. These are 1-foot contours. I love the 1-foot contours. You see these red spots. I've been there. He's got severe erosion. We're looking at maybe putting some water and sediment control basins there. We've got a waterway already up here. We've got a filter strip, buffer strip planned here, and he's going to tile drain this. This whole field will be pattern tiled. So we're looking at maybe a saturated buffer on that field. So it's a great tool to get it started. And here's that field again. It's a moderate risk of runoff compared to the parameters that they put together. How close to the stream are they? What's the slope? What are the phosphorus levels? No, that's not in there. But sediment delivery and so on. So it's a good tool. And I would think that conservation districts would want to get some training in this, whether they got a watershed grant or not. I think it's a great tool for technicians. Okay, last thing. Here's a field where, an example field where we're doing a systems approach. This was one farm now, but it was 3 separate farms that were bought by a producer, and we decided, look, we're going to try to do everything we can in this field to reduce erosion and improve and mitigate phosphorus loss. So you can see this farm. We've got a couple washouts here where we put wash cobs in. If you've ever seen a wash cob, I'm not going to explain it to you. Come out to the farm. We've got blind inlets. Instead of orange risers, we've got blind inlets in. We've got a I knew this was going to happen. We got a diversion over here, and we've got a saturated buffer down here. So this is, see the pattern tile? This is 40-foot spacing. This is rolling land, and that's the south branch of the River Raisin. So this is no-till, going to be a no-till system, cover crops, drainage, subsurface drainage, wash cobs, we're controlling erosion. How can we treat the water at the lower end? How can I make this work right? So I want to talk a little bit about saturated buffers because we worked on it last week. In fact, I think there's mud on my shoes still. Saturated buffer is a process of treating upstream subsurface drainage water from phosphorus and nitrogen, primarily nitrogen. We're gonna make this a harvestable buffer. Yeah, we're gonna make this a harvestable buffer here, so we can remove the phosphorus. So if we're controlling water levels and it's got phosphorus in it, we're going to remove that with a 40-foot harvestable buffer. So there's the top view of it. This is the actual farm. You can see all the tile lines here. We're going to have 51 acres going down through this 1,400 foot of saturated buffer. We've got 5 water control. I tell you, 5 water control structures so that we can control the water table in the buffer when there's an 18-inch difference in elevation. So we can hold that water at certain times of year close to the surface, okay? We also are working with Asan Ghani on sampling at both ends of the buffer, so we can evaluate the benefits of the practice, kind of back to what the gentleman talked about on adaptive management. Having good data so farmers can apply. I like the practice because it's reasonably priced to install. If we get good water quality benefits, will be great. Here's an example of one of the water control structures. You can see the transmission lines here. That transmission lines are for the water. This controls every 18 inches difference. These water control structures control the elevation difference. Here's another picture of it. Here's the main tile. Here's all the laterals coming in. Oops. And here's the transmission lines. Here's the south branch of the River Raisin. And then we're going to have a grass alfalfa strip to about there. We want to keep the main out of the vegetation. So with that, I will close. Thanks for the opportunity, and hope there's some questions.
Yeah. Thank you.